Hello everybody, welcome to FVD tutorials, and today we're gonna be learning how to make a diving machine drop by using this program. I already have the lift hill and the station here, and let's just go ahead and get started. So first of all, at the end of this section here, we have to add a curved section, as usual in most of the diving machines in real life. So we're gonna adjust the radius to approximately 11, no, I think 8, yeah, 9, yeah, 9 should be fine. As you guys might already know, the train moves by itself at this point, so that means that there has to be a pitch so that it can move by gravity, okay? So we can add this pitch by adjusting the direction to approximately 95. That gives a pitch of -5, okay? However, as you already noticed, there's a roll associated with it. So we have to adjust it because right after this it comes a straight segment. So we're gonna adjust it to until we get 0, exactly 0 here. It's very important that you get 0, nothing less or more than that. Yeah, that should be fine. We have a pitch of -5. And then we're gonna add a straight section of approximately 8 meters. The pitch is the same here, -5. And now it comes to the most important part, the pre-drop. So we all know that at this part, there's a segment where the speed is controlled. More specifically speaking, the speed is approximately 0. I don't think it reaches exactly 0 in real life, but it's something very close to 0. Here in FVD, we cannot set the speed of controlled sections to exactly 0, and by control sections I mean curved sections and straight sections where we can fix the speed, okay? So the least that we can get here is 0.1 meters per second, which is reasonable, and I think it's enough for our purposes. So after that, we're gonna go ahead and add a curved section. Obviously, it has to be something very slight, okay? It has to be very small. So we're gonna adjust the direction to 180 because it's going down. We're gonna adjust the radius to exactly 5, should be fine. We should also adjust the total angle to 35. Okay? I don't know why I set the speed to 0.1 here because this part doesn't really matter. I'm sorry. It should be approximately 0 here where the pre-drop comes. Okay? So, one last important thing that we have to adjust here is the lead out. Because if you keep a lead out of something more than 0, the program just assumes that there's gonna be a straight section right after it. And that's not what we want, right? So from this point to about the middle of the drop, we know that the behavior of the shape of the track is curved because the train is trying to reach a 0G, okay? Of course, if it's gonna be a sort of straight drop, it means that the train is gonna reach 0. It's exactly 90 degrees to the ground. So we already have our speed set, we already have our angles, lead out here, everything set. Now we can add a force section. Let's just drag it to the point where we're gonna be working on, which is here. So we're gonna lock the lateral force section, we're gonna lock the roll section, and we're gonna leave the normal force section unlocked, because that's where we're gonna be working on. So we have something approximately equal to 0.766 G, and we want this to be 0, okay? Okay, yeah, we have pretty much 0. That's not quite the drop that we want. So we all know that from this point to the middle, there's gonna be something curvy here, about here. So we necessarily have to increase the length of the segment, okay? We can increase it to about 2.4. If we need, we can adjust it later. It depends on the total height of the total length of the segment. That's not quite a drop yet, so what we need to do here is adjust the pitch so that we can get something very close or exactly equal to 90 degrees. So in order to do that, we have to change the type of the orientation. I mean, not the orientation, the type of the segment. And this type is going to be quartic. And within quartic, we're going to select overshoot final value, okay? This is 0.801, but let's just put it 0 for now. Overshoot final value means that we're gonna have 0 at the end, as we previously said, but we're gonna have a change in g-force. There's gonna be beyond the natural course of the mathematical function, okay? So by increasing this overshoot, by increasing this thing here that I don't know the name, we're gonna adjust the pitch here until it reaches approximately 90. We're getting there. I like to be very accurate, so we're gonna waste some time here. Okay, so now 0.764 should be fine. We already have approximately 90 degrees. And you can also mess a little bit with those tension and center here, but right now I'm not gonna do it because I already have the value that I was looking for. So that's basically half of the drop, okay? So now we're gonna add this new G-force section and set it to 4, because that's the bottom of the drop. And I like to use quintic, so let's just set it to quintic to make it smoother. And then we're gonna add a new subsection of the section just to finish our drop right here, okay? So now we have finished. The drop has reached the ground. We're just gonna adjust a little bit more here to make the pitch 0, approximately 0. Okay, now we have it, and that's pretty much it. We have our diving machine drop. It's pretty much like the real ones. That might not be the best shape ever, but that's the easiest way to do it, and also the fastest. That's the only way that I know how to do it. Okay, I hope you guys have enjoyed it, and thanks for watching.